Hi everyone, I welcome you all to this video. This video deals with the basic concepts of a vector and the two important theorems, that is parallelogram law of forces and triangle law of forces. You can see the flow chart. Physics is a branch of science that deals with the study of particles, objects or matter. Mechanics is a branch of physics that deals with the study of forces acting on an object or a particle. Mechanics can be classified into dynamics and statistics. Dynamics is a branch of mechanics that deals with the study of forces, that under the influence of forces the object remains in motion, whereas statics deals with the study of forces. Under the influence of forces the object remains at rest. A force is a vector quantity. Vector means it has both magnitude and direction. Vector is represented by an arrow. For example, car travels at 5 km speed towards east. Here, 5 km represents the magnitude and towards east is the direction. So it has both magnitude and direction. An example for a vector. Force is a vector quantity. It has both magnitude and direction, and along with that the position, the point where the force is acted. Parallelogram law of forces. If two vectors acting on a particle at a point be represented in magnitude and direction by the two adjacent sides of the parallelogram drawn from a point, then their resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the point. So, if two forces acting at a point can be represented in magnitude and direction by the two adjacent sides of the parallelogram, then we can find the resultant as the diagonal of the parallelogram. The resultant is also a vector, therefore it has both magnitude and direction. The magnitude of the resultant can be found as root of p square plus q square plus 2pq cos alpha, and its direction can be given by in terms of theta, that is theta is equal to tan inverse of q sin alpha divided by p plus q cos alpha. Let vector p and vector q be two forces acting at the point O, inclined at an angle theta. These two forces p and q can be represented in magnitude by the direction by the two sides OA and OB of the parallelogram OACB. Now by vector addition, when we add two vectors, OA vector plus AC vector is equal to OC vector. From the figure it is clear AC is parallel to OA. Therefore, if AC is equal to Q vector, then OB is also Q vector. Replacing AC as OB vector, we get OA vector plus OB vector is equal to OC vector. And next, OA is equal to P vector and OB is equal to Q vector and OC is equal to R vector. Finally, P vector plus Q vector is equal to R vector. Therefore, the resultant vector R vector can be represented by the diagonal OC of the parallelogram OACB. The resultant is a vector quantity, therefore we have to find the magnitude and direction. To find the magnitude and direction, we are going to draw the perpendicular CD to the line OA. From the figure it is clear, angle AOB is equal to alpha and AC is equal to OB is equal to Q vector and OA is equal to BC is equal to P vector, since they are parallel. Also, the angle AOB is equal to angle CAD, that is equal to alpha. Consider the right angle triangle, then we are going to use Pythagoras theorem. In the right angle triangle ODC, we get hypotenuse square is equal to sum of squares of other two sides. Therefore, OC square is equal to OD square plus CD square. Replacing OD by OA plus AD, we get OA plus AD the whole square plus CD square. Let it be. Consider the another right angle triangle ACD. Here using trigonometric ratios, we get sin alpha is equal to CD by AC. That is equal to CD is equal to AC sin alpha. AC we know it is Q, therefore CD is equal to Q sin alpha. Also from right angle triangle ADC, we are applying cos of angle cos alpha is equal to adjacent side by hypotenuse, that is AD by AC. Now AD is equal to AC cos alpha. AC replaced with Q, we get AD is equal to Q cos alpha. Substituting the value of CD and AD in OC square, we get OC square is equal to OA plus Q cos alpha whole square plus Q sin alpha whole square. Using A plus B the whole square formula, we are going to expand and simplify. We are getting R square is equal to P square plus Q square plus 2PQ cos alpha, where the resultant magnitude R is equal to square root of P square plus Q square plus 2PQ cos alpha. Next one, the direction of the resultant. We are going to find the direction of the resultant in terms of angle. Let alpha be the angle between the resultant R and the vector P. From the triangle OCD, right angle triangle, we are applying tan of angle, that is tan alpha is equal to opposite side by adjacent side, CD divided by OD is equal to CD divided by OA plus AD. Replacing CD as Q sin alpha theta and AD as Q cos theta, we get theta is equal to tan inverse of Q sin theta divided by P plus Q cos theta, which is the direction of the resultant. Therefore, using parallelogram law of forces, we have found the resultant of two forces. Similarly, we can also use triangle law of forces to find the result of two forces. The statement for the triangle law of forces is, if two forces acting at a point are represented in magnitude and direction by the two adjacent sides of the triangle taken in order, then the closing side of the triangle taken in the reversed order represents the resultant of the forces in magnitude and direction. In other terms, if three forces acting at a point are represented by the three adjacent sides of the triangle taken in order, then the three forces are in equilibrium. Now, the proof for this theorem. Look at the figure. Let vector P, vector Q and vector R be three forces acting at the point O, and these three forces can be represented by the three sides AB, BC and CA of the triangle ABC. We have to prove that the three forces are in equilibrium. Therefore, we have to say vector P plus vector Q plus vector R is equal to 0. Sum of the forces is equal to 0. For the purpose of proof, we are going to complete the parallelogram ABCD. AB is parallel to DC, that is P vector, and BC is parallel to AD, that is Q. By parallelogram law of forces, vector P and vector Q can be represented as the two adjacent sides AB and AD of the triangle of the parallelogram. Therefore, the resultant is given by AC. Vector P plus vector Q is equal to AB plus AD vector is equal to AC vector. By triangle law, the third vector, vector R, is represented by CA. Now, vector P plus vector plus Q plus vector R is equal to, vector P plus vector Q can be replaced as AC vector and R vector can be written as CA vector. Changing the direction, we get AC vector minus of AC vector, that is equal to 0. Since the sum of the forces is equal to 0, we can say the three forces are in equilibrium. Hence, the proof for triangle law of forces. Thank you.